Hi everyone, Quiveen here from the comfort of my kitchen. In today's video, we are going to firstly take a look at an object that I have shown before, the Ring Nebula in Lyra. The Ring Nebula in Lyra is a fantastic object to try and take a look at. Medium to large telescopes will give you a view of this distant object, not even a particularly big object in space. Certainly bigger than a planet, and the name Planetary Nebula is not the best, but like the names of so many things, like the Crab Nebula, the reason its name is what it is just because telescopes weren't quite as good in the past. Getting an accurate view of these very distant objects is tricky. Now, I started zooming in without even talking about it. Here we are looking south early in the evening. Over the next few weeks, really, we'll have the summer triangle nice and high in the sky, basically as soon as the sun goes down, because we're out of summer, so it's not going to be sticking with us the whole night long anymore. Vega or Altair, one of them should set before the sun rises. We're looking up towards Vega, the brightest star in the triangle, right there at the edge, and this Vega is in the constellation of Lyra. And Lyra is where we find the Ring Nebula. Now, it is very difficult to see. It's certainly impossible to see with the naked eye. But I'm hoping if I zoom in to roughly the right location, it might pop up for me. There we go. Yeah, the Ring Nebula, an annular nebula, a planetary nebula. Annular or ring is a great description because it is. It's this kind of ring-shaped circle, and with this lovely high-quality image, it definitely doesn't look like a planet. But to early astronomers, this looked like a round shape in the sky. And if you start zooming in on stars, they tend to remain point-like. No matter how closely you look, you need an incredibly big telescope to see a star as an actual sphere in space. It's something we can do today, but not so easy in the past. This, because of its round shape, it reminded astronomers of planets. Once you start zooming in on planets, their round shape is revealed. You can see that they're round and not just points of light. Zooming in on this shape, Charles Messier probably thought he saw a comet, but this shape looked a lot like a planet. And Charles Messier was a comet hunter who happened to find a bunch of other objects. This is number 57 on the Messier list, and that list goes up into the early hundreds. 111, 112, quite a lot of objects. The Ring Nebula is probably my favorite example of a planetary nebula because it's up for the entire summer here in Ireland, and at the right time of the night, a couple of hours in the evening before and after as well, or a couple of hours in the morning. The Ring Nebula is right there next to Lyra. It's such a famous part of the sky. Unfortunately, the Ring Nebula is kind of small and difficult to see, and there are other planetary nebula that show a lot more of the interesting internal structure. Planetary nebula aren't planets. What they are is the remains of a star. They're the remains of a star similar to our sun that has blown up. Any star that's too big, this nebula, oh no, I lost it. This nebula has a particular name. This is the name it is given, and the reason it is given this name is because this nebula looks like it's wearing a parka. Parka is a particular type of jacket with the a big hood and a furry ring around the outside. If we take a closer look at the nebula here, we will hopefully see what I'm talking about. There we go. So the idea is that that's a face in the middle, and that's the kind of fluffy ring of the parka. So Clownface Nebula, also an option that you could call it. However, this is the more famous name. I won't get into it. This is another planetary nebula, and we can see a very similar structure here. It's got this lovely circular shape, a really perfect circle, but we can see that there's definitely differences to the internal structure compared to what we saw with the Ring Nebula. There are a lot of these nebulae. I'll check if I have a list of them. So the planetary nebulae are the remains of a star similar to our sun that has reached the end of its life. Very often these stars cool down as they get older, but once their core starts fusing different materials coming to the end of its life, the core of the star will heat up the outer layers, which will cause them to expand and eventually drift off into space. Yeah, so there's some good ones here. Dumbbell Nebula, doesn't have a picture. That's okay. I'll check if the Calabash one is in here. Of course, we can see these ones with proper names, and those were probably discovered earlier in the history of discovering these things. Calabash Nebula does not seem to be there. Let's try the normal Dumbbell Nebula. Oh, zoomed in a little bit too close. There we go. It's got this kind of round shape. You're probably not seeing why it looks like a dumbbell or a Diablo or an apple core here, but it does kind of expand there at the top and at the bottom and is narrower in the middle. It is tough to see in this image. Let's see if that makes it look a little bit better. Yeah, so we can see it's kind of got these lobes. So when a star like our sun, or a small star, it doesn't necessarily have to be like our sun much other than its size. When a star like our sun finally blows its outer layers into space, the magnetic field of the star, the rate at which it's spinning, any wobble that the star has, that's going to affect how these layers blow off, and the structure that the resulting cloud of gas, the resulting nebula, which is not a planet at all, it's going to influence how that looks. So we get a lot of these different internal structures depending on the nature of the star, and trying to figure out exactly what stellar characteristics give rise to what kinds of planetary nebulas. It's a whole thing. Magnetohydrodynamics, the study of how magnetic fields flow and interact, is as complicated as hydrodynamics, but with electromagnetism added in. It is a tricky thing. You can see here from the names that a lot of these, well, this one's a little distant and hard to spot, does kind of look like a scarab beetle. Actually, that's interesting. But Bowtie Nebula, a calabash is a type of gourd that's usually swollen on two ends and narrower in the middle. It's often used for the transport of water. Dumbbells, of course, are dumbbell-shaped. Diablo, similar. The Hourglass Nebula, same thing. These shapes come from how material is affected by the magnetic field of the star, which, of course, runs from north to south. So it gives these lobes, this kind of lobed or double-ended shape to these planetary nebula and to their precursor. Now, I wonder if that's in here too. Protoplanetary nebulae. There's the Calabash Nebula, so it's protoplanetary rather than planetary. My mistake. These are the precursors. So a planetary nebula is the cloud of material, gas, plasma, that's after emanating from a star. But this is the star just as it's falling apart, just as those materials are getting thrown out. So planetary nebula and protoplanetary nebula especially, they are transient stellar phenomenon compared to the grand scale of stellar evolution. Rotten Egg Nebula is a bit of a nasty name. Calabash Nebula sounds better, but there is some wacky colors there for sure. This is just as the material's getting shot out. You haven't gotten that full circular ring yet. You're really seeing the material as directed by the magnetic field and the motion of the star, the motion that the star still has. So this kind of thing, it only lasts for a few tens of thousands of years, maybe 100,000 if we go all the way into planetary nebula, compared to the millions of years that even comparatively short-lived stars burn through. Our sun will last for billions of years. And remember, these protoplanetary and planetary nebulae, they only come from smaller stars, which are often, generally, more long-lived than the larger ones. So a small star like our sun can be, for billions of years, burning away in its main phase. It'll have a bit of time, a million years, couple of million years, going through its final evolution, moving off the main branch, and then falling apart. And for just tens to hundreds of thousands of years, you will have those planetary and protoplanetary nebulae as the remains of the star. So Egg Nebula, that's my favorite protoplanetary nebula. It is up in the Summer Triangle as well. So it's not, I almost said it's not a million miles away from the Ring Nebula. I believe it is actually millions, trillions and trillions of kilometers away. It's definitely quite a few light years away, but it's not too far away in the sky. They're in similar enough locations, and it doesn't have an image. The Egg Nebula, the Cygnus Egg, is a nice planetary nebula if you can get an image of it. Apparently not as easy as I thought. We'll get rid of the ground here so we can see the Boomerang Nebula, which also doesn't have an image. I am slightly disappointed. But at least we got to see the Calabash Nebula, which does have that fantastic name. So the protoplanetary nebulae are the very beginnings of a star falling apart, shedding its outer layers into space, not collapsing in on itself in a supernova. So it has to be a star too small for a supernova like our sun. This is what's going to happen to our sun. Our sun, in billions of years, we've got so much time left, but our sun is eventually going to fall apart in that sort of graceful, gradual way, leaving behind this brightly colored, transient phenomenon for just a really short period of time for any part of stellar evolution. Apparently, the Calabash Nebula is the only one I've got a picture of. Hopefully, I'll be able to find another here somewhere. Oh, lost it. At least there are plenty of planetary nebula that we've got good images of. Of course, because protoplanetary nebula are even more transient than planetary nebula, they don't last for very long, and so we generally see fewer of them in space. We're only looking at a snapshot of time here, the length of the human lifespan. So there are going to be fewer of these short-lived phenomenon visible in the sky, and the protoplanetary stage of a planetary nebula lasts even shorter than the planetary stage. And as I say, it's the remains of a planet. It's the remains of a star. There is nothing planetary about it. And we do have planets in the sky if you'd like to compare what they look like through a telescope. I hope you do get to see some of the planetary nebula. They are a really fascinating niche part of stellar evolution. It's something that only happens to smaller stars. So supernovas and black holes get a lot of the attention. But that's where our solar system is heading. So I hope that you enjoyed this look at planetary and protoplanetary nebulae. If you did, please do like this video. And if you'd like to support more videos, you can subscribe to my YouTube channel. That really helps. You can also read some of this information on my website if you would like to read it. And hopefully I will see you back here again next time.